arrays. So arrays are data structures that allow us to collect together a large number of data items of the same type. So these could be integers, booleans and so on, but later on we'll see how they can group together more complicated items. Arrays are always of a fixed size, so once they're created they can't change size. In order to use an array we have to go through a two-stage process. First we need to declare it, and then we need to create it. So these two stages are probably best illustrated if we consider the question of how we might store a bunch of marks. So the first question is, how do we represent each mark? And the second question is, how many do we need to store? So the representation question concerns the declaration. So how do we represent each mark? And the second question, how many, concerns the creation of the array. So here's how we declare that we want to use an array of integers. That is, we want to store a group of integers that collectively we want to call student mark. So here's a literal interpretation of scanning this line of code. We say declare an integer array called student mark. Okay? We declare an integer array called student mark. So the first part of the declaration specifies the type of data that we're storing in this array, in this case integers. Okay, so every item in the array needs to be of the same type. We can't mix and match. So the double square bracket is notation to specify that we're creating an array of something. So we can think of it rather like a box. To me it looks a bit like a box into which we're putting a group of items. So if we simply said int student mark without the box, then that would just create a single data item, a single integer variable called student mark. But here, because we've got this notation here, we're essentially saying give me a box of integers and call it student mark. So we specify the name of our array here, and the usual rules apply to naming arrays just as with any other variable. Okay, and then we terminate the line with a semicolon. So we've declared our array, but now we actually need to create it, because all the declaration does is create an empty reference to an array called student mark. But of course we need to allocate memory to it. So until the system knows how many items we want in our array, 10, 10,000, a million, it has no way of knowing how much storage to reserve for it. So we need to specifically state this, and we do this by creating the array. So we say that student mark is the result of a new reservation of 20 integers. Okay, so the new operator is used to construct new things, and we'll make a lot more use of this later on. So here we're essentially saying student mark is a new integer array of size 20. Okay, so student mark is a new integer array of size 20. So as we said, we need to specify the number of items, and we can use a constant here or even a variable so long as it has a non-zero value when we create the array. And whatever we use here, the size of the array is fixed at the time of creation. So now that we've created our array, let's go ahead and use it. And the first step in this is to populate the array, is to give each item in it a value. So when we create an array, we can't assume anything about its contents. So we have to initialize each item. Okay, otherwise each item will essentially be undefined. So in order to do this, we need a way of being able to individually reference each item, and we achieve this using an array index, which is always an integer. So we can think of the index rather like a room number. We have an array of rooms, each room is individually numbered, and the array index specifies a particular room. So instead of saying in the old bad way of doing things, student 10 gets the value 76, we might say the 10th element of the student mark array gets the value 76. Okay, so here we're using an index to refer to the 10th element of the student mark array. which gets the value 76. So we access the array using the array index by specifying it using the square bracket notation. So here the number 10 is the index. But of course, as we'll see shortly, we don't have to use hard-coded values, otherwise we wouldn't get the benefit of using arrays. So here we're simply saying, just to reiterate, give the 10th element of the student mark array the value 76. But obviously, as we just mentioned, using hard-coded values for the index isn't much good, because the key thing is that we don't have to use fixed numbers. We can use the value of a variable. So in fact, it's not actually any different if we say this here. It's just as inefficient, really. So we have to have some way of having a variable to access each element of the array. So knowing that, what's the basic algorithm to clear every element in an array to 0? Not the code, just the algorithm. If we know that we can use a variable here rather than a constant value. So pause the movie, have a think about what the basic algorithm is for clearing an array, that is setting every element in an array to 0. So here's the algorithm. We just have a counter, which we call E here, E for element, and we loop over the array using E as the index to clear each element in turn. So we basically say for each element E in the array, set value of element E to 0. And here's some code that implements this basic algorithm. So we're using the student mark array as our example. So we declare a constant, which is the number of students that we'll handle in our array, and here we've set it to 20. Okay, and then we want to declare that we want to use an array of integers to store our student marks, and then create it using the size that we've just defined, in this case num_students. So here we declare the array called student mark, and then here we create it using the new operator and the number of students constant that we've just declared at the top. Then here we use the for loop to iterate over the array. So it's just a standard for loop which we set the index to 0 and then loop. So long as the index is less than num_students, remember, and we'll come back to this later, because we start from 0, we stop before index is equal to the number of students. We need to be less than number of students. And every time around the loop, we add 1 to index, okay, which is achieved using this shorthand notation ++. So if you just want to add 1 to your index every time around the for loop, you can simply say whatever the index variable is, ++. So we can access each element of the array using the index, just as we've done before, as we've done in the loop body, and here we can use it to set each element to 0 in turn. So here the for loop index goes from 0 to num_students -1, and every time around the loop index is ticking up by 1. So the first time around the loop it will be student mark 0 equals 0. Next time around the loop student mark index will then have the value 1. So student mark 1 takes the value 0, and so on and so on and so on.